Hello. So, everybody, we are going to do our last lesson for Unit 5.8, called the Rational Zero Theorem. We are going to determine how many zeros a polynomial has. This is actually something we've already done, so that's a real minor part of this. We're going to generate a list of possible zeros. So if we know that a polynomial has, let's say, 4 zeros. We're not going to know exactly what they are. We got to figure out what they are, but there's a list that we'll be able to figure out that kind of clues us in on that. Now, it looks pretty complicated, so I copied this from the interweb. First of all, a polynomial is that. That's what a polynomial looks like the formula for any generic polynomial. And then the theorem says that polynomial has any rational roots. They must be of the form plus minus factors of a sub 0 divided by factors of a sub n. Well, first of all, black is an awful color to highlight with. And second of all, reading mathematical theorems is just an awful thing to do anyway. So I try to avoid teaching that theorem, and I just teach this. We're going to make a list out of the plus minus factors of the last number divided by the first number. And when I get to the actual homework down here in notes, you'll see what I mean. But this whole part of the theorem, I mean, it matters mathematically speaking, but as far as how we apply it to class, doesn't really matter. What's in pink is what I'm going to explain. Now, so we're going to come up with this list of possible zeros, or zeros, roots, same thing. And we're going to test them. We'll see which ones are actual zeros. So we've got a list of possibilities. We're going to test them to find the actual answers. Remember, when you do synthetic division, oops, don't mean to erase there, I mean to highlight, a zero remainder means that we have found a zero. If you have not yet learned the synthetic division, you have to go back to that lesson. Scroll back through Google Classroom, find the one on synthetic division. You have to know how to do this. Finally, not every root is going to be rational. If they're rational, they are in this form. That's what it says. If it has any, they must be in that form. Okay, that was awful, highlighting all that. Sometimes the roots are imaginary or irrational. That can happen. So once you've found all the rational roots, you can find out any leftovers that are imaginary or irrational. The first few examples are not going to have imaginary or irrational roots. And remember, roots and zeros, same thing. But we can use factoring or the quadratic formula later on when we need to. Okay, so let's look at number 3. Or number 3? No. Number 2. I do the evens, you do the odds. First of all, it's a third degree polynomial. There are going to be a total of 3 roots. They might all be rational. They might be rational, a mix of rational and irrational, or rational and imaginary. There's all sorts of possibilities. But one thing we can do is make our list of possible rational roots. Sorry about that. So how do you find the list of possible rational roots? So you do plus minus factors of the last number divided by factors of the first number. So last over first. So what are the factors of the last number? The factors of 1 are simply 1. The factors of 5 are 1 and 5, right? You can divide 5 by 1 and 5. So if I want to make a list out of this, I'm going to have 1 divided by 1, which is 1, so plus or minus 1. And I'm going to have 1 divided by 5, which is plus or minus 1/5. So plus or minus means positive or negative. So the list itself is actually -1, +1, -1/5, +1/5. That's a lot of writing, and no one actually wants to write that much out. So we usually leave it like that. But I want you to keep in mind, when you see 1 and 1/5, that's not 2 roots, that's 4 roots, because there's positive and negative each one. So there are a total of 3 roots, because it's a third degree polynomial, and we've got a list of 4 roots to choose from. So finding this list is part of your answer. Circle it or something so that I know you did it. Now we need to see and test which of those roots actually work. So I'm going to set up synthetic division. Remember how that works. So you put these coefficients, 5, 1, -5, -1. And your divisor goes out here. And so you could pick any divisor you want, right? You could pick the number 8 and then do synthetic division. 5, 40, 41. 41 times 8 is 328. And that's 323. And then 8 times 323 is, I don't know what. But the point is, does that give you a 0 remainder? So whatever this times this is, if I write it here, when I add it to -1, do I get a 0 remainder? No, I don't. Without a 0 remainder, we're nowhere. I mean, the 0 remainder tells us that the number we divided is a 0. So you wouldn't pick just random numbers like 8 or whatever. You want to pick numbers out of this list. So what do we want to choose? How about if we start with 1? Bring down a 5, multiply 1 times 5 is 5. Add 1 plus 5, that's 6. Multiply 1 times 6 is 6. Put it here. -5 plus 6 is 1. 1 times 1 is 1. -1 plus 1 is 0. Positive 1 worked. It is a root. Let's try positive 1/5. Hold on. Try to make this look neat with nice straight lines. Okay, let's try 1/5. Bring down the 5, multiply 1/5 times 5. 1/5 times 5 is 1. 6 plus 1 is 7. 1/5 times 7 is 7/5. And if I add those together, do I get a 0 here? No, I don't. What is 1 plus 7/5? Like 12/5? Not that it matters. It doesn't matter. It fails. We want a 0 remainder. That's what we're looking for. That's all that really matters. Since that fails, well, using the iPad, I can just erase my work and start over with something else. If you're doing this on paper, hopefully you're using a pencil so you can erase it. If you're using a pen, that's about the worst thing you could do. Anyway, 1/5 failed. So I tried positive 1, it worked. I tried positive 1/5, it didn't work. Let me now try -1. Bring down the 5. -1 times 5 is -5. 6 minus 5 is 1. -1 times 1 is -1. 1 minus 1 is 0. Again, a 0 remainder is good. We're finding zeros, right? We're finding roots. Roots are also called zeros. They're called zeros because they give us a 0 remainder, maybe. I don't know. And again, there's 3 of them, and we've just found 2 of them. There's one more. So we tried 1, it worked. We tried 1/5, it didn't work. We tried -1, it worked. How much you want to bet the next one is -1/5? Bring down the 5. -1/5 times 5. Okay, 1/5 of 5 is 1. Negative times positive negative, so that's -1. 1 minus 1 is 0. So -1/5 works as well. So positive 1, -1, and -1/5 are the 3 zeros, or the 3 roots for this polynomial. When you check your work, you want to check your list to make sure it was right, and then your actual answers to make sure they're right. So let's look at number 2. Here's our list of possibles, and there's our answer. So I wrote 1, -1, and -1/5. They gave their answers in a different order, but it's the same thing. So we are good. All right, so now what do you need to know? Well, we're going to do a few more for the sake of repetition, because it helps to see it done a couple of times to make sure you get it. You need to see problems that have like tricks to them or extra steps or things that don't fit, the standard flow of that first problem. This was kind of an easy one. So yeah, follow along. The ones toward the very end, the last couple, 12 and 14, are going to be significantly more complicated. So if you do skip around, make sure you catch those. All right, so anyway, so we've got to make our list of possible zeros. So what are the possible zeros? Factors of the last number, plus or minus, over factors of the first number. The factors of 1, simply 1. The factors of 2, 1 and 2, right? You can divide by 1 or 2. So if we expand this, 1 divided by 1 plus or minus 1. 1 divided by 2. Well, 1 divided by 2, you could call it 0.5. I'm going to sneeze in a minute. Sorry about that. 1 divided by 2, you could call it 0.5 or just leave it as a fraction, 1/2. Normally, fractions are the way they go. So, okay. So now set up the synthetic division. Oops. I guess I kind of forgot one detail. There are, again, 3 roots. We have to find all 3 of them. And we've got a list here of 4 possibilities. Positive 1, negative 1, positive 1/2, negative 1/2. So, bring down our coefficients. 2, negative 3, 0, 1. Okay, what happened there? So this is a 3rd degree polynomial. That means we should have an x cubed term, an x squared term, an x to the 1st power, and then a constant. And this polynomial goes 3, 2, skips over the 1st power. So you need to put 0 as a placeholder. And then 1 is the constant at the end. If you forget that placeholder right there, you will get this wrong. So you have to put that 0 in. That's very, very important. Okay, so now we need to start testing our possibilities. Let's do positive 1. Bring down a 2. 1 times 2 is 2. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. 1 times negative 1 is negative 1. 1 minus 1 is 0. That worked. So we've got 1 of our 3 answers is found. Let's find another. Let's try, how about negative 1? Bring down the 2. Negative 1 times 2 is negative 2. Negative 1 minus 2 is negative 3. Negative 1 times negative 3 is positive 3. Negative 1 plus 3 is 2. We do not have that 0 remainder that we want, so negative 1 is a fail. Positive 1 worked, negative 1 failed. Let's try 1/2. Bring down the 2. Half of 2 is 1. Negative 1 plus 1 is 0. Half of 0 is 0. Ooh, negative 1 plus 0 is negative 1. That failed also. Interesting. Did I do anything wrong? No. Legitimately failed. So what's left? Well, negative 1/2. Bring down the 2. Half of 2 is 1, but times negative, that's going to be negative 1. Negative 1 is negative 2. Negative half times negative 2. A negative times a negative is positive. Half of 2 is 1. So, oops, don't want to erase that. Negative 1 plus 1 is 0. A 0 remainder, remember, means success. Negative 1/2 is an answer. So we found our second answer. And remember, there are 3 of them. But we've tried all 4 from our list. Positive 1 worked, negative 1 failed. Positive 1/2 failed, negative 1/2 worked. How can there be another one? Well, if you recall from previous lessons, there's something called multiplicity. The same answer can work more than once. So I'm going to try positive 1 all over again. Bring down a 2. Multiply 1 times 2 is 2. Negative 2 plus 2 is 0. A 0 remainder means success. So, did we find 3 answers? Yeah, 1, 2, 3. Once, twice, I didn't mean to say that. 1, 2, 3. We have 3 answers, but 2 of the answers are the same answer. So how do we write this out? Well, negative 1/2 is an answer. Positive 1 is an answer with a multiplicity of 2. So we have our list of possible answers and then the actual answers. And we use synthetic division to figure it out. Let's check number 4. And there's our list, and there's our answers. Cool. Number 6. Okay, so we're going to make our list of, there are going to be, again, 3rd degree polynomial, 3 roots, 3 zeros, 3 answers, whatever you want to call it. The possibilities are plus or minus factors of the last number. The last number is 3, so what can you divide into 3? 1 and 3. Over the first number, which is also a 3, So that's another 1 or 3. Now, if we make every possible fraction out of that, we've got 1 over 1. So that's going to be 1 over 1 is 1, plus or minus. 1 over 3 is 1/3, so plus or minus 1/3. 3 over 1, 3 over 1 is 3, so plus or minus 3. And then 3 over 3, plus or minus 3 over 3. Well, 3 over 3 just reduces to 1, which is already on the list. So you don't need to write it down twice. We're good with that. So this is our list of possible answers. Now, here's a tip. I haven't done it on the first few problems, but let's go down and check that part of number 6. I don't want to cheat so much, but then again, I don't want to start doing a problem. So plus or minus 1, 3, and 1/3. I don't want to cheat, but I don't want to start doing a problem with wrong, a wrong list of possibilities, because that would make it awful. Okay, so now I set up the synthetic division. 3, 13, 13, 3. And notice we have the whole descending order. 3, 2, 1, constant. So I didn't need to put in any placeholder like I did up here. All right, so now we need to test these numbers. What are we going to test? Well, this problem actually has something a little special about it. You see how every number is positive? Remember, in the end, we want a 0 here. The only way to get a 0 is at some point to have a minus 3 right there, right? 3 minus 3 is 0. And the only way to get a minus here is to introduce a minus into the problem. There's no negatives anywhere else. If there were negatives somewhere in this problem, then everything would be fair game. But just a little tip, when everything's positive, you've got to try negatives. So even though we've got, our list is 2, 4, 6 numbers long, we really only need to try the negative numbers. So let's go ahead and start with -1. Oops. Don't know if it's going to work, but let's try it. So bring down the first number. -1 times 3 is -3. 13 minus 3 is 10. -1 times 10 is -10. 13 minus 10 is 3. -1 times 3 is -3. 3 minus 3 is 0. Now, here's another thing. So I can keep going with the synthetic division. I can try -1 again because multiplicity happens. I can try -1/3, or I can try -3. And eventually I'll get answers. But here's another option. So this was originally x to the 3rd power. You could write this as 3x squared plus 10x plus 3, and then factor it if you want to. I mean, if you like factoring, you can do this. You don't have to do synthetic division. Once you get down to 3 numbers, hey, if you like to factor, stop the synthetic and do this. Now, honestly, most people don't like to factor when there's a lead coefficient out there. It's kind of a pain. Another option, though, if you want to, is you could call this A, B, and C, and then you could use the quadratic formula. Remember this? So you can plug in 3, 10, and 3 into the quadratic formula and work that out. All right, let's be honest. Most people don't like doing that either. I just want to point out that it's a possibility. At this point in the process, you do have options. When you get down to 3 numbers, you can factor or do the quadratic formula. I think on this particular problem, I'm going to choose to keep doing the synthetic division. It seems the easiest way. So I doubt -1 is going to work again, because that'd give me a -3, which is a 7, and yeah, that's not going to be good. So let's try -3. Bring down a 3. -3 times 3 is -9. 10 minus 9 is 1. -3 times 1 is -3. That's a 0. Now here we have one more, right? There's 3 total. We found 2. Can you look at the 3 and the 1 here and just kind of reason through it? What's going to work? I think it's got to be -1/3, right? To cancel out the 3 and the 1. Bring down a 3. -1/3 times 3 is -1. 1 minus 1 is 0. So we get -1, -3, and -1/3 as our three roots, or three zeros. All right, let's check those on number 6. Oops, too far. And there it is. Written in a different order, but yeah, right answer. Okay, number 8. Now, for the rest of this worksheet, number 8, 10, 12, yeah, and even 14, yep. Something is happening in every single one of these problems that we need to take care of. Every term has an x in it, so there's a common factor. You can factor out that x. You get 3x to the third minus x squared minus 3x plus 1 equals 0. And with one of the factors being x, that means with this thing set equal to 0, then x equals 0 is going to be one of your answers. So we've covered how to factor before. Set this x equal to 0, that's one of your answers. So there are going to be 4 answers, 4 roots, because it's a 4th degree polynomial. But because there's a common factor of x, we factor it out. That means x equals 0 is one of the answers. So you have to deal with that before doing the rest of the problem the way I've been explaining it. To do the rest of the problem the way I've been explaining it, now we make our list of possible answers. Plus or minus last number over first number. Now, our last number is 1 and our first number is 3. Up here, there was no last number. It was a last variable, and you can't do that. It's got to be a constant. So factor out the x. That's one of our 4 answers. Now we have 3 more to go, right? So factors of the last number. Last number is 1, so that's just 1. First number is 3. That's 1 or 3, right? You can divide that by 1 or 3. That gives us plus or minus 1 divided by 1 is 1. Plus or minus 1 divided by 3 is 1/3. There's our list of possible roots. To do synthetic division, you completely disregard the x that we factored out. That's done. We've got that answer accounted for. All you have to do is worry about what's in parentheses. 3, -1, -3, 1. Now, this has a mix of negatives and positives, so it's not like the last problem where we knew every answer had to be a negative. When you got a mix of positives and negatives, it could go either way. So just test numbers. I'm going to test +1. Bring down a 3, multiply it. Add it, you get 2, multiply it. Add it, you get -1, multiply it, you get -1. Now, in every problem, +1 has worked. Oh no, it didn't work here, did it? But -1 did. Does that mean either +1 or -1 is always going to work? Not necessarily. I mean, math is infinite. There's infinite possibilities. There's no guarantee that 1 or -1 is always going to work. But it looks like when a computer generates random homework problems, there's kind of a good chance that 1 or -1 is going to be a result. So keep that in mind. Anyway, oh yes, I forgot, 0. That was the whole point, right? You're trying to find a 0 remainder, so I better write that down. Now we keep dividing. Again, let me stop. If you want to, you make this 3x squared plus 2x minus 1 and factor it, or do the quadratic formula. That's up to you. I'm going to continue doing the synthetic division. Oh man, I can't do anything neat and orderly. There, that's better. Okay, so what do you want to try next? I wish we could participate here. Let's try -1. Bring down a 3. -1 times 3 is -3. 2 minus 3 is -1. -1 times -1 is +1. -1 plus 1, 0. So there's our second answer. 1 more to go. And this is kind of like a previous problem we did. What's it going to take to cancel out the 3 and the -1? I think it's going to take 1/3. Bring down a 3. 1/3 times 3 is 1. -1 plus 1, 0. So there's the third answer. 1, -1, and 1/3. I keep calling them answers. Okay, you're supposed to call them zeros or possibly call them roots. Anyway, let's check number 8. Make sure I didn't mess anything up, because you know me, I can mess things up. Good, and oh, okay, here's my 3 answers. I forgot about the 0 from the very first step. So this 0 up here, I probably should have brought down and included it in my answers like that. All right, cool. Number 10, same thing as the last one. There's a common factor of x, so you have to pull out the x. You get 3x to the third minus 15x squared minus 2x plus 10 equals 0. That means x equals 0 is one of our roots. So there are 4. One of them has to be 0. There's 3 left. We'll make our list of possibilities. So plus minus factors of the last number. Ooh, this is going to be interesting. We actually have a big number. I mean, it's not big, but 10 can be divided by 1 and 10 or 2 and 5, right? And then the first number is 3. That one seems to pop up a lot. 3 can be divided by 1 and 3. So now this is going to be a bit of a pain. So we have plus or minus. 1 over 1 is 1. 1 over 3 plus or minus 1/3. Then we have 10 over 1 plus or minus 10. Then we have 10 over 3, 10/3 plus or minus. Then there's 2 over 1, which is plus or minus 2. 2 over 3 plus or minus 2/3. Look, I'm running out of space. 5 over 1 plus or minus 5. And 5 over 3 plus or minus 5/3. So there are 3 zeros left, and we have 2, 4, 6, 8, 10, 12, 14, 16 choices, 16 possibilities to choose from. This is where this type of math gets to be really not fun because there's so much trial and error. And we can't even rule out some of the negatives or some of the positives like in that one problem. So yeah, we just got to try and be prepared to fail a lot and do a lot of erasing. So let's try 1, bring down a 3. That's 3, that's negative 12, that's negative 12. Negative 2 minus 12 is negative 14. That's negative 14, and that does not give us 0. So positive 1 is a failure. Let's try negative 1. That's negative 3. Negative 15 minus 3 is negative 18. That's positive 18. That's 16. Negative 16. That does not give us 0 either. So negative 1 is a failure. So look, positive 1 and negative 1, no guarantee that they work. All right, everyone hates fractions, so let's try another whole number. Let's skip over to 2. 2. So 3, 2 times 3 is 6. Negative 15 and 6 is negative 9. That's negative 18. That's negative 20. 2 times 20 is 40. I don't think so. Let's go for negative 2. So bring down a 3. That's negative 6. Negative 21. Negative 42. Negative 44. Okay, that's a big no. Now this is where going fast and making arithmetic mistakes can really bite you in the rear end, or however you want to say it. So yeah, I could have already made mistakes and I don't even know yet. Let me try 5. So bring down a 3. 3 times 5 is 15, and that's 0. Now that's interesting, but we need 0 in the last place, the remainder place. So don't get too hopeful yet. 5 times 0 is 0. Negative 2 and 0 is negative 2. 5 times negative 2 is negative 10, and that does give us a 0 there. So yay, 5 works. There were 4, but one of them is automatically 0, which means there were 3. Now we have 2 left. Now here, this might be interesting to not do the continued synthetic division, because we have to keep trying all those numbers. Instead, let's look at this as 3x squared. That 0 is technically, plus 0x minus 2. But in algebra, if you're really doing algebra, you wouldn't include 0x, right? So what we have here is basically 3x squared minus 2 equals 0. And this we can solve. We don't even have to factor it. We can just add 2 to both sides. That cancels out. 3x squared equals 2. Divide both sides by 3. You get x squared equals 2/3. Remember how to solve for x. You have to square root both sides. Square root cancels out the square. And also, anytime you square root, it's the square root property. You have to put a plus minus in front of it. And that gives us the square root of 2 over square root of 3. And then we have this rule about square roots. Boy, has this come up in this class? I don't remember. You're not allowed to have a square root in the bottom of a fraction. You have to multiply by square root of 3 over square root of 3. Yeah, we've done this. So it's called rationalizing the denominator. You get plus or minus. On the top, if you multiply this, you get square root of 6. And on the bottom, you get square root of 9. But the square root of 9 is 3, right? You can simplify square root of 9. So that's plus or minus square root of 6 over 3. Now, what the heck is that? That's not in the list. But that's okay. This list only gives us possible rational roots. Again, there's no guarantee that all the roots are going to be rational. Like I said at the very beginning, some roots can be complex, or I'm sorry, imaginary. Some roots can be irrational. A radical is an irrational number. So, what the heck does this mean? Well, this was our list of possible zeros. I'm trying to circle it. So remember, that's part of your answer. When you check yourself, you got to have that. And then to find the actual answers, one of them up here was 0. One of them right here is 5. There's a total of 4. The other two are positive radical 6 over 3 and negative radical 6 over 3. Those are the solutions. Here's our list, lengthy. It's in a different order, but it's all there. And then here are the actual answers. 0, 5, radical 6 over 3, negative radical 6 over 3. If you look at when you do number 9, it's going to be real similar to that. Except I don't know if you're going to have to do that funky rationalizing thing. Hopefully not. All right, where are we? 2 more and we're done. Number 12. Again, you got to factor out that x. 3x to the third plus x squared plus 15x plus 5, which means one of our roots, one of our zeros, is 0. We make our list of possible answers, possible rational answers, plus or minus last number, which is 5, that's 1 or 5, over first number, 3, 1 or 3. Make every fraction. 1 over 1 is 1. 1 over 3, 1/3. 5 over 1 is 5. And 5 over 3, 5/3. Find out which ones are the correct roots. Remember, we're looking for 0 remainder. So 3, 1, 15, 5. Oh, lucky day. All of these are positive. Again, as a little tip, we're only going to try negative ones. Let's start with negative 1. So that's negative 3, negative 2, positive 2, 17, negative 17. That does not work. Let's try negative 5. I don't know about you, but I like saving the fractions for last. 3, multiply that's negative 15, negative 14. 5 times 14 is positive 70, 85. That's not going to work. There's no way we're going to get a 0 remainder out of that mess. So negative 5 didn't work. All right, time for fractions. Let's try negative 1/3. Bring down a 3. 1/3 of 3 is 1. Multiply by negative, that's negative 1. 1 minus 1 is 0. Negative 1/3 times 0 is 0. Bring down the 15. Negative 1/3 times 15 is negative 5. 5 minus 5 is 0. I could keep going, but I think it's going to fail with every possible answer. Let me double check. I could do negative 1/3 again because it could be a multiplicity. Multiply negative 1/3 times 3 is negative 1. That's negative 1. Negative 1/3 times negative 1 is positive 1/3. That does not give us a 0. So no multiplicity. 1 and 5 didn't work. Positive numbers aren't going to work. Let's try negative 5/3. Bring down a 3. All right, what is negative 5/3 times 3? Negative 5/3, the 3's cancel, you get negative 5. 0 minus 5 is negative 5. Negative 5/3 times negative 5 is 25/3. 15 and 25/3 does not give us 0. So yeah, everything else failed. That means that we've got to do the same thing we did in the last problem, where this is 3x squared plus 0x plus 15. But remember, the 0x doesn't really matter. So you just have 3x squared plus 15 equals 0. Now we'll go ahead and solve this. So I'll subtract 15. 3x squared equals negative 15. Divide both sides by 3. X squared equals negative 5. Square root both sides to cancel out the square. Remember, you always have to put a plus minus down. You cannot square root 5, and 5 is not the type of number that'll break down into anything simpler. So that's just going to be radical 5. But we do square root a negative. Remember what it's called when you square root a negative? If you just said imaginary, you are correct. So I radical 5. This has two imaginary numbers with a radical in them. So what are the answers? 0 was one answer. Negative 1/3 is another answer. Positive I radical 5. And negative I radical 5. And don't forget our list. Nope, that wasn't the list. The list is right here. Our list of possibilities. So I've circled too many things. Let me just leave my final answers circled and I will check them. Some one of these days. So here is our list. Okay, list 0 is a possible rational root. I don't really do that because it's automatically an answer, but okay, take it for what it's worth. And then of course those answers right there. If your list doesn't have 0, I'm not too bothered by it. All right, let's do number 14. I peeked at the answer. Did you see that? All right, again, there is an x in common that you can factor out, so I'm going to do it. Minus x to the third minus 9x squared plus x plus 4 equals 0. It's a 5th degree polynomial. That means there's going to be 5 zeros, but one of them is automatically x. That's a given. For the rest of them, we need to make our list of possible answers or possible roots. So that's plus or minus last number over first number. The last number is 4, so we've got 1 and 4 or 2 and 2. Now I'm not going to put 2 down twice. You don't have to. Just put it down once. That's fine. The first number is 5, so that's 1 and 5. So if we make our list out of this, it's going to give us plus or minus 1 over 1 is 1. 1 over 5 is 1/5, plus or minus. 4 over 1 is 4, plus or minus. 4 over 5 is, well, 4 over 5, plus or minus 4/5. 2 over 1 is plus or minus 2. And I can almost fit this in. I'm going to cheat a little. And the last is 2 over 5 plus or minus 2/5. Now when I go to do my synthetic division, I've got my possible numbers to choose from. Let me bring this down there. So I got my coefficients. And what number should we try first? How about 1? We always want to start with 1. 5, 5, 4, 4, negative 5, negative 5. 1 minus 5 is negative 4. 1 times 0. It worked. So I kind of rushed through that. I'm hoping you're getting the hang of synthetic division. You don't need me to explain every step every time. So there we go. 1 worked. Could 1 work again? It's possible. There is something called multiplicity. Let me try that. 5, 9, 9. Negative 5 plus 9 is 4. 1 times 4 is 4. That's 0. Look at that. Could 1 work again? Technically, multiplicity doesn't have to be 2. It could be 3. You could have the same answer 3 times. 5, 5, 14, 14. But it doesn't work here. 14 plus 14 is 18, not 0. So not this time. In fact, if I was using my head, I would have noticed that these are all positive at this point. So I might as well only just use negative answers. So let's try, or negative possibilities. Let's try -1. Bring down a 5. -1 times 5 is -5. 9 minus 5 is 4. -1 times 4 is -4, and that's 0. And now for the last one, to cancel out the 4 and the 5, well, I bet I'm going to have to use 4/5. And again, it's going to have to be negative because both of these numbers are positive. So bring down the 5. -4/5 times 5. The 5's cancel. That's -4. 4 minus 4 is 0. So it was a 5th degree polynomial. That means there are 5 answers, 5 zeros. One of them is 0. The other 4 are 1, which happens twice. So 1 has a multiplicity of 2. And then -1. And then -4/5. So when we check ourselves, this was our list of possible answers. I don't really have to have that circled up there. That should be it. And I do believe the list is correct, except again, their list includes 0. Since I already know 0 is an answer, I just don't see the point in putting it in that list. And then here's the answers, again, with the multiplicity there. So there we go. So, man, I'm sure you don't want to see more lecture, but if you're in the mood, one thing you could have done, if we back the truck up to this point, we could have made this, oops, not that, 5x squared plus 9x plus 4. We could have done that equals 0. And then if you're really good at factoring, like 5x and x, and then what, 4 and 1 plus and plus, then you set this equal to 0 and set this equal to 0, and then work these out. Divide by 5. There's that answer, -1. There's that answer. So I guess I'm just illustrating that there's other options for getting this done. If you don't like the synthetic division, when you get down to 3 numbers, you can resort to other tactics. Sometimes you have to resort to other tactics because you get imaginary numbers or irrational numbers. So, all right, I'm going to stop there. This is a complicated lesson. I'm not going to sugarcoat it. I'm not going to try to lie to you. It's complicated. The math you're doing, when it comes down to it, is adding, subtracting, and multiplying. So you're not doing difficult math. It's just putting it all together is complicated. So if you find yourself having trouble, having issues, please contact me, or you can Google this topic or search it on YouTube and find other videos that may be helpful. I can do a meet with you. You can come to the class meet on Algebra 2 is Monday and Thursday, so show up there if you have questions. Otherwise, get this assignment done. Don't forget to show your work and check your work. And until I talk to you later, have